Hi, this is Mrs. Weens, and today I'm going to teach you about fractions. Fractions are a very important part of everyday life, and if you haven't learned about them already, you're going to hear some great things today. And if you're already familiar, then it will be a review. So you'll need a pencil and your notes and just some listening ears. So I was having a little bit of trouble with my software, so I have to open up these files while I'm talking to you, but hopefully you guys can bear with me here. Okay, so first let's just talk about what a fraction is here. So it all kind of goes back to counting and what we need to do in order to count everything. So if you look at how many hexagons are here, you can count 1, 2, 3, 4, 5 hexagons. But what if we wanted to just count one part of a hexagon? What if we just had this shape? How would we count it? Well, we wouldn't call that one hexagon, would we? It's not a full hexagon. So that's why we need to come up with something like fractions. It's a way about talking about parts of a whole. So fractions are for counting part of something. That's what they're for. So if you take a hexagon and break it into 6 equal pieces, if you have one of the pieces, that would be called 1 out of every 6 pieces, right? Well, in fractions, we write it as 1 over 6. So the top number is called the numerator, and the bottom number is called the denominator. But we say 1/6 more commonly than saying 1 over 6. Now, what if I asked you how much of this hexagon is red? Well, 1, 2, 3, 4, 5 pieces are red out of 6 total pieces. So we'd say 5 out of 6 are red. So 1 blue piece out of 6, 1/6 of the hexagon is blue, and 5/6 is red. So what if we had this rectangle? Okay, so here you see some purple and some yellow, but how much purple and how much yellow? Well, we need to break it into even parts first. So now each of these sections is the same size. So we're able to see how much there is of each. So altogether we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sections. 1, 2, 3, 4 of them are yellow. So 4/9 is yellow, and 1, 2, 3, 4, 5/9 is purple. So we're going to formalize this on our note. So you can start copying down what I have here, okay? The purpose of fractions is so that we can count part of something, okay? A fraction is a part of a whole. So for example, I have this example here, a numerator 3 over a denominator 5. Sorry about that. So the numerator simply means that we are going to look at that many parts. So in this case, we're looking at 3 parts. The denominator means that's how many parts make a whole. So 5 parts, in this case, equals 1 whole. So we could draw a picture of that here by drawing something that takes up 5 parts to make a whole, 1, 2, 3, 4, 5, and then to show 3/5, we could just color in 3 of them. So that's 3/5. Okay, now we want to talk about equivalent fractions. So I'll go back to here. So equivalent fractions are 2 fractions that are the same, just represented differently. So if you look at these 2 circles, the same amount is red in both circles, but we can call it 2 different things. In this circle, we would say 1/2, and in this circle, we would say 3 out of 6. Notice that it's the same amount of red, but we just call it different things because this circle was in 2 pieces and this circle was in 6 pieces. So those are called equivalent fractions since they're equal amounts. So if you look at this, it's the same thing. Here we say 1/3 is green because 1 out of 3 pieces is green, but this shape has been broken up into 9 pieces. But 3 out of 9 is the same thing as 1 out of 3. So if we look at this example, we see 2 red out of 4, And here we see 1, 2, 3, 4, 5, 6, 7, 8 out of 16. So 2 out of 4 and 8 out of 16 are the same. So let's go back to our note. So equivalent fractions represent the same number. So for example, 1/2 equals 3 over 6. You know that this works because to get from 1 to 3, you multiply by 3. And to get from 2 to 6, you also multiply by 3. So that's how you can come up with an equivalent fraction. You multiply the top and the bottom by the same number. Here, 2, to get to 4, you multiply by 2. And 5, you multiply by 2 as well. So 5 times 2 is 10. 2 times 2 is 4. So these are equivalent. Okay, again here, 1 to 2, you multiply by 2. And from 3 to 6, you multiply by 2. So now we want to be able to reduce fractions. Okay, so we want them to be able to be written in their lowest terms. This is important because we want it to be as simple as possible. So to do this, we reduce the fraction. So we don't want to write 7 out of 21 because that's not in its simplest form. Okay, we want to write it so it's as small as possible. So we want to find an equivalent fraction that has smaller numbers on the top and the bottom. So we do that by dividing the numerator and the denominator by the same number. So we think about numbers that they can both be divided by. And we need to get it as small as possible. So 7 can be divided by 1 and 7. And 21 can be divided by 1, 3, 7, and 21. So they can both be divided by 7. Okay? So that means we want to divide the top and the bottom both by 7. So we get 7 divided by 7 over 21 divided by 7. We're allowed to do this because we're doing the same thing to the top and the bottom. So that gives us 1. 7 divided by 7 is 1 over 3. 21 divided by 7 is 3. What about this one? Well, 3 and 12 are both divisible by 3. So we divide them both by 3. 3 divided by 3 and 12 divided by 3. So you get 1 over 4. Now 72 divided by 81, these numbers are a bit bigger, so you might have to get a calculator out and see what number they're both divisible by, but they are both divisible by 9. So 72 divided by 9, okay, if you know your times tables, you should recognize that. I highly recommend coming into high school, you do have the times tables up to 12 memorized. Okay, so this would be 8 divided by 9. Now you know something is in lowest terms if you can't divide it by any smaller numbers. So 8 and 9 have nothing in common that if they're divisible by, they have no common factors, so you know that that's the lowest number. So hint, you only have to divide one time if you always divide by the greatest common factor. And I hope you've learned about that in your elementary school. Now, how can you tell if something is bigger? Okay, let's go back to that McDonald's and A&W video you watched. We care about which fraction is bigger. So 1 over 4 or 1 out of 10, which one is bigger? Well, 1 out of 4 is saying 1 out of 4 pieces. That's what it means, right? And 1 out of 10 is like if you take that same pizza and you're still getting 1 piece, but it's out of 10 pieces. So which piece is going to be bigger? The one that's 1 out of 4 or 1 out of 10? Definitely 1 out of 4 is going to be bigger than 1 out of 10. So that's how you can tell if a fraction is bigger. Now what about if you have 3 over 8 or 7 over 8? Well, would you rather have 3 pieces of 8 or 7 pieces of 8? Clearly, 7 of these 8 pieces is more pizza than just 3 of them. So 7 over 8 is bigger than 3 over 8. Okay, But in our last example here, it's not as obvious. So we have to kind of just use our heads and think. What's bigger, 3 out of 10 or 5 out of 26? Okay, so 3 out of 10 isn't a lot, but 5 out of 26, well, 26 pieces is a lot of pieces, and 3 really isn't much of them at all. So 3 of 10 pieces is actually going to be bigger than 5 of 26. Okay, what about 2 out of 11 or 5 out of 6? Well, let's think about that. If we have something broken down into 11 pieces, 2 of them isn't very much. And if we have something broken up into 6 pieces and get all 5, almost all of it, you get 5 out of the 6, that has to be way bigger. So 5 over 6 is bigger than 2 over 11. And finally, 1 over 4 or 1 over 3. Well, 4 is a bigger number, so you might think it's bigger, but that means that a whole is divided into 4 pieces. So 1 piece out of 4 pieces is actually going to be smaller than 1 piece out of 3 pieces. If you need to draw a picture, you can. So here's 1 out of 4 pieces, and here's 1 out of 3 pieces. That's bigger. So 1 over 3 is bigger than 1 over 4. Okay, down here I just put some stuff that you need to know for grade 9. I hope you enjoyed this video on fractions. Thanks for watching, and I hope you learned lots.